From Microbe TV, this is Matters Microbial, a podcast about the wonders of microbiology, microbiologists, and microbial centrism. This episode was recorded on July 24th, 2025. Hello, Micronauts, and welcome once again to our Quality Quorum. I'm your host, Dr. Mark Martin, Associate Professor of Biology at the University of Puget Sound in Tacoma, Washington. Today is the 102nd episode of Matters Microbial. Many thanks to every listener, viewer, guest, and supporter. It means so very much. As most of you surely know by now, I am particularly interested in strange and unusual microbes to be found in equally odd environments. The Puget Sound area had quite a lumber industry for about a century, and a great deal of wood waste has been buried at the seashore. When the tide goes out, some of those areas have outgoing seawater, extremely rich in hydrogen sulfide. As we've talked about before, last week in fact, this hydrogen sulfide is a great source of high-energy electrons, and in fact, geochemically generated hydrogen sulfide drives some hydrothermal vent communities. A little easier to get to here. Around these sulfide seeps in Puget Sound, we find rocks covered with very large filaments, as seen here. I had one of my summer research students, Micronaut Hannah, collect some of these filaments, as you can see in this tube. Even at a low magnification under a microscope, one can see clusters of filaments, seen here. Finally, in this close-up, which I'm particularly pleased with, you can observe a filament with sulfur inclusions inside the cell. Hannah also found many interesting groups of filaments, seen here. So who goes there, microbially speaking? There's a great deal known about thiotropic, sulfur-loving communities, and I cannot wait to see how these sulfide seep inhabitants compare. I'll keep you all posted, funds permitting, of course. For many years, I have tried very hard to use myriad strategies to enhance student understanding of and appreciation for the microbial world. First evolved, last extinct. Base of the biosphere. There are many ways to accomplish this, and I'm always delighted to learn more. For this reason, I am honored to introduce Dr. Dvita Smith of Texas A&M San Antonio to discuss her fascinating approaches to making students feel really connected to the relevance of microbiology in and out of lecture classes. Welcome to the Quality Quorum, Dvita.
I'm delighted to be here.
It was so wonderful to see you at ASM Microbe last month, and not just because of your awesome accent.
It comes with me wherever I go.
Now, first, I wanted to remind listeners and viewers that Dvita is the 2024 American Society for Microbiology Karski Award winner for promoting undergraduate excellence in microbiology. In addition, she is an American Society for Microbiology Distinguished Lecturer. Also, Dvita, could you tell the listeners and viewers about the National Center for Science and Civic Engagement and your role in that organization?
Oh, sure. But before I do, I will say I'm so beyond honored to have received those awards. When I received the Distinguished Lecturer Award, my head exploded. And then to receive the Karski Award, because it's such an honor to be in the same room with all the previous awardees. So I'm very grateful to ASM, and I've been a very long time member. Not as long as you, but I'm a long time member. For the National Center for Science and Civic Engagement, this was an organization that I am the deputy director of. It's a non-profit organization. And I've been involved with it for pretty much as long as I'm a professor. Maybe the second year of my academic career, I got the opportunity to attend what we call a Censor Summer Institute. And my work at the time was looking at helping our students read the textbook, because we were having a lot of issues with students not engaging with the textbook. And I was involved in a project called Reading Effectively Across the Disciplines at the time. And when I went to this organization's meeting, same thing, my head exploded, because most of the folks there were not all scientists, to be frank. They were English literature professors, economists, mathematicians, engineers. But all of these folks attending wanted to teach students to think scientifically and to encourage them to think scientifically about the world through effectively teaching issues of importance, right? What we would call capacious wicked issues. And there was kind of a philosophy among the organization members to kind of not focus on content necessarily, not focus on the nitty-gritty factoids of the science, but rather how science can be used to address these issues. And at that time, it was so profound to me. I didn't think I could go there. I was stuck following these textbook indexes and tables of contents, and it really blew my mind. So the first step was I became what's called a Center Leadership Fellow. And that was wonderful, because at the time, what they would do is they would give out these kind of small grants, institutional awards, seed money effectively, so you could get your project going. And then eventually they made me a fellow, which meant that I got a press release. And, I'm an Irish immigrant working in America, so to get a press release about me was such an honor. And my institute obviously put out this word about me. And then from then, I was able to kind of take the first steps to being like what we call a change agent, because you have this little kind of bow and you can say I'm a fellow. And from then I worked with Centre for several years until I was asked to step in as the Deputy Director of the National Centre for Science and Civic Engagement. And now my job is to help other faculty learn and do and have the same experience I had, and to try and fund us and get grants and to promote effectively professional development in the organisation. So it has had the most profound impact on me. And again, most of what I know comes from people who are not scientists. So it's a major thing.
I mean, I find that to be and we've all seen the business of Thomas Kuhn trying to talk about different ways of knowing, for lack of a better term.
Yes.
But I really do believe, look at the history of molecular biology. I've said it more than once on this program, that the real founding of molecular biology, with all due respect to some of the biochemists that were involved in it, were physicists, quantum physicists, that actually got into it. They were looking for a model system. They were thinking the way that physicists do. That was part of the phage revolution, Max Delbrück and others, and Gunther Stent. Yeah. So, what I'm trying to say by all of this is that bringing other ideas in, I think, really increases perspective.
100%. So, and right now, I have an engineer from West Texas, Eric Butler, who is in my lab right now, doing qPCR for wastewater pathogens. He's following on from another PhD student of mine called Jasper Brambiamillen, who came over from Delft to study in the lab for a few weeks, and he basically was doing again PCR molecular biology in the bench. I love having folks who aren't necessarily microbiologists in my lab, because it does offer a perspective, and I can give you an actual example of this.
Please.
Yes. So when during the pandemic, myself and colleagues, we got a lot of press for the work we were doing with wastewater epidemiology in New York City. And that was a marvelous collaborative effort across several institutions in New York City. But in parallel, we were doing work on aerosols. So at the time, if you recall, we were studying the impact of the 6-foot rule. In New York had a very different experience during the pandemic, perhaps to other cities. And we were in the middle of it all in New York City. But at the time, all their institutions we were locked down, and at the time the advice was the 6-foot rule, right? And at the time we were very interested in this, because as a microbiologist who just knows about how things transmit, we were like, well, that doesn't seem to make sense to us if the microbe was able to travel in the air, which so many microbes could do. So we leveraged a tool called Phe6, which was a labeled phage that we basically used. I actually have a slide that I can show you, and I'm going to point to that slide right now. But in that experiment, basically, we leveraged what's called like a nebulizer, basically, where you normally wear it on your face like such. We turned it around like this. We put a phage lysate in there, and we aerosolized the phage into the air. And we set up detectors, which were simply petri dishes with the host of the phage on the surface,
Mm-hmm.
and we allowed the phage to travel through the air, and we set it up at 3 feet, 6 feet, 9 feet, blah, 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 from there. And the very first experiment we did, the very first one, and these never work, the very first one, the phage got 23 feet into the classroom's air in about 15 minutes. So we were like, instantly we knew if you had a source, the 6-foot thing wasn't going to work. And we were working in a building that had a very, very advanced AC system, and which should have been able to remove the phage from the air. But here's the kicker. So about halfway through the experiment, would have been midsummer. It was very humid in New York, very humid. The experiment stopped working. We couldn't see, our petri dishes are vertical, we couldn't see the phage hit the petri dishes. And I was at a loss. I was checking my phage. I was like, did I kill the phage? Did I kill my lysate? Did I kill the host? Well, I was trying troubleshooting, as you do. Mm-hmm. And what I didn't mention was one of the team members, Anton, was a physicist. Actual physicist, not microbiologist at all, physicist. And he was helping us with the modelling and everything else. And Anton pipes up and goes, well, it's very humid. And we were like, and he's like, I wonder, is the humidity impacting how far the phage is getting in the air? And myself and my colleague, Fabrizio, effectively we did this, Of course. So all we did was we took our petri dishes that were vertical, put them horizontal, and there was the phage landing onto the petri dishes. So effectively, as it was traveling through the air, it was getting too humidified and forming droplets and falling out of the air. The whole premise of the paper that we wrote was that when the humidity got above 40%, which is known, right? This is known phenomenon. There's not actually a lot historically available on the experiments that came to that premise, to that conclusion. But once it got to 40%, the phage was out of the air. Therefore, it would be similar for other things. So we looked at the relative humidity of the room, and we took that into account. And every time the relative humidity went above 40%, our phage would start dropping out. And what we were able to do is we used, because it was during lockdown, we bought really cheap humidifiers, like really, really cheap ones. And then we set up some pilots where we increased the humidity. And as the humidity increased, our phage wasn't able to hit. So it was a wonderful experiment. And it all came from the physicist in the room who was not thinking the way we were. He was thinking a different way. And that just goes to show. And I've had countless experiences like that, where someone who is not from science land, I shouldn't say not scientist, he is a scientist, but you know what I mean, not from a microbiologist perspective, would come at a problem in an entirely different way. So for me, interdisciplinarity is critical for a greater understanding of the world. And so when I teach, when I try to engage my students, I always try to bring in as many other distinct, diverse perspectives as I can. Because honestly, diverse teams get stuff done. That's just the way it is. So we don't do a good enough job of it, to be frank.
First off, for listeners and viewers, the experiment that Dvita's talking about uses a bacterial virus, a bacteriophage that we've talked about on this program before. And just in case this worries anybody, I promise you it's okay to aerosolize it.
Oh, yeah.
And it's really, no. I have people ask me this quite often. And I think it's really, really important to remember that. This is a wonderful way to study it because, as you said, if it works for this bacterial virus, it will work for other things, including SARS-CoV-2. By the way, did you know the story about when people first started doing phage work and they made the mistake of using phage T1?
Tell me more.
Once you work on phage T1, you always work on phage T1. You cannot get rid of it.
You can't get, it's always there.
Yeah. And I heard horror stories when I was, in college from some of the older faculty about it. And it's not a surprise necessarily. It has nothing to do with us. But, this is a wonderful example, as you say, of bringing in a different perspective and how that really informs what you're doing. Sometimes because the person coming in doesn't know what a good question is. And in fact, their questions are good.
Of course. And I think there are no bad questions. That's, I've actually I gave a talk several years ago, and I said that in my very ineloquent way of saying things, always be questioning. I mean, that's the first step of any scientific way of looking at the world, is that you never accept what you see in front of you. Always ask questions. And if you should be, every step of your day should be, I wonder, how, why, what? And I think if you approach the world that way, you'll have a lovely, rich life.
It's a version of the Ted Lasso quote. Be curious, not judgmental, right?
I just finished Ted Lasso last night. That's so funny. Yeah, I mean
Yeah.
it's a way to approach the world. And I think I
Mm-hmm.
actually another thing I got from Censor was and another meeting was the Right Question Institute, and it's another technique I use in my classes. There are questions that are simple enough to answer, the yes nos, but what we're trying to do is have our students ask questions where the answer isn't simple, and that's kind of the basis of a scientific experiment, right? So it's a process called I can't remember now what it's called exactly, but it's a process whereby I have the students go out into the world during class, make observations, make as many observations as you can. And then when you come back, I want you to write down as many questions as you can on the basis of the observation that you made. And so I give them like 10 minutes or so. And then I poll the students and I ask them who came up with 5 questions, who came up with 10 questions, who came up with 20 questions. And we have fun and all of that, a little kind of competition. And then after that, you have them look at the questions that they asked and turn them into better questions. So in essence, can you just answer that question right now? What about the questions you can't answer right now? And so I have them do that, and then they're thinking about the question formulation theory. That's what it's called. And in essence, they come up with better questions. And then I say, well, that is the first step in developing a scientific question, right? So in essence, now, if you were to make observations and you were thinking about something in a scientific way, the questions that you've come up with would basically form the basis of your experimental design. And that's how I lead them into experimental design and all of that. So I think forming questions is an art. And I think that students should practice, because at the end of the day, they're going to spend a good chunk of their career trying to answer questions, be it on exams or be it in the lab. So if they understand how we formulate these questions, they will be able to more effectively answer them.
I would go farther than that, Dvita. I would say that it's central to critical thinking.
100%.
And people shut themselves down. I mean, I've been teaching way too many years, and I've noticed, from all that time, students are often afraid to ask questions and I don't know where this is from. And if I can find the people who did it, I'm going to give them a wedgie collectively. But
Collective wedgie.
well, because these students are afraid of being made fun of.
Oh yes. Well, that's
I want to be clear for a minute. There are such things as uninformed or unprepared questions. Unprepared question, so what? I mean, and I actually have a quote about this. It's from me. That I don't know is not a negative thing. It's an opportunity to learn.
100%.
And so when I have students who'll say I don't know, sometimes they do that because they're afraid to engage. No, I want them to engage. I could care less what ChatGPT says. I want to know what they think.
Oh, 100%. And so for me, one of the things I've always tried to do, my classrooms are kind of different. So I paint my classrooms as, and again, I say to my students at the start of class, I said, you're in Vegas. You're in a safe, comfortable, friendly space in as much as I can make it so. And I think it's even more important now to do this. So another strategy is you can have what's called a classroom agreement. This is a technique I learned when I was at the new school. A classroom agreement is something that you sometimes the faculty member will make it, and sometimes the students make it, sometimes students and faculty member comes together and designs it. But what I've been doing of late is I ask the students, I give them a prompt very simply, and I ask them, when do you feel most comfortable during a learning experience? When is that most comfortable for you? And then I put it out to the class and I ask them, tell me when you're most comfortable. We do it on Padlet. So effectively they can all write when they feel most comfortable. So for example, when the professor is respectful and listens to us and doesn't whatever. And then they all write these things and then I have them go through and rate them. So which one do you agree with? Which is the one that you really agree with? And then from that process, we develop our classroom agreement. And the reason why it's important is, as I said, I want my students to feel 100% comfortable to ask me whatever question they want to ask. And as I said, it's very important now because we are going to come up with controversial things that used to be controversial, to be frank, but now are. And I want my students to be able to have those 2-sided or 3-sided or 4-sided conversations around those issues. Because if they can't do it in a classroom, in a learning environment where they're supposed to be able to think, empathize, relate, see other people's perspectives, engage with those things and think about them critically, what's the point of education? So they have to be able to ask questions. And I actually challenge my students not only to advocate for themselves and to speak up for themselves and everything else, but also to not think of me as the all-knowing one, because science is not perfect. And that's a censor philosophy. So one of our things is that science is not perfect. So there are limits to science. It's powerful, but it's very limited at the same time because it's a human endeavor. And scientists make mistakes. But we have processes in place to address those mistakes and to learn from our mistakes and to continue. It's a continual process of learning, coming up with new ideas, coming up with new hypotheses, new theories and everything else. It is a process. It's not static. Science is never static. And so I spend a lot of time teaching my students that. And so I'm hoping that by the end of it, they don't look at science as being a all-knowing thing. They look at it as being a process of discovery, a way of looking at the world, a way of engaging with what's in front of you. And then, as I said, being able to ask questions and not necessarily trust what you're being told, because that's really important. You have to be able to go to the source of the data for yourself, ask the questions, look at the evidence in front of you, and make an evidence-driven decision on the basis of what you've seen. And that's the thing, is teaching our students how to understand sources of information, be able to question the validity of those sources, understand what a well-researched article is, etc., etc., and then they can make those draw conclusions in the world. I'm trying to get them to not literally take what they're being told at face value. They have to think beyond that, and that's the goal of an educator.
One of the things, two things. First is, we had a diversity consultant in my department a few years ago who said something that's really stayed with me. She didn't like the expression safe space.
Yes.
She preferred the expression brave space.
Yes.
And it really touched me, because that is the goal.
100%.
Right?
Yes.
Secondly, well, actually, there's three things I want to say. There are some professors, some scientists who don't want to say, I don't know, to something. And we fool no one when we don't admit it.
I'm very, very comfortable saying I don't know.
Right.
I do it all the time.
No, you should, because that's an opportunity to learn new things. So the reason I bring this up is that I have seen educators, and these are good people who really care about their craft, who've said things to me like, if you say I don't know to a student, they won't respect you. I have never found that to be the case.
Neither have I.
I have always found it to be a case. It actually helps respect on a mutual level in the classroom. Thirdly, and something that I want listeners and viewers to remember, and Dvita, I know that you've gone through this one, but I still see this in the media about there are 10 times more bacteria in and on us than there are cells of us. And you see it everywhere. And it turns out that when you dig into that, and I'll put a link in the show notes, that number was completely made up.
Yes. And I actually have it in my lectures because I talk about that. So in essence, no, I mean, this is the thing. I mean, we do ourselves a disservice because, as I said, I agree with what you said about I don't know. I think the issue with the I don't know question is it comes from folks who perhaps have been in a position where they've always had to fight for the authority that they have, right? So, for example, when a man, not to be mean here, but when a man says I don't know, it sometimes is different from when a woman says it, and we often see that there can be gender-specific discrimination and
there is
racial discrimination for faculty. So some faculty, when they say I don't know, some people would say, well, I know, of course you don't know, and that can come back to bite us sometimes. But I think the approach that we're trying to take here is that we're trying to emphasize that the more human you appear to your students, the more flawed you appear in a way to your students, the more honest you can be with your students. I think what I would like to do is, rather than say I don't know, is I say I don't know right now, but I'm going to go learn about that. And then therefore it shows my students that whereas I can't possibly know everything, I'm just a human being. But where I don't know, I'll find out. But more often than not, what I will do is if they ask me something I don't know, I turn the table on them and I say, why don't you educate me about this? And so I will actually put it to them. I actually don't know the answer to that question. Why would you mind very much finding out the answer for me and telling me next time we come to class? And I've done that many, many times to my students. And that way they're like, oh my God, she's actually asking me. She understands that I might know something. And that happens, to be honest with you, I'm a foreigner. I might be I'm a naturalized American, but I'm a foreigner, so I don't have cultural context that folks have here. I won't understand a lot of the references. I don't know most of the 80s culture the students or whatever grew up with. I just don't know it. So oftentimes I get stumped, and that's okay.
So really and truly, it's a collaborative situation. That's what
Yes.
education really is. It's collaborative.
100%.
And you know, when one person teaches, both learn. You know, that old canard, but it's also true. And so I really think it's important to have that connection with students. Again, I can't speak to how education is in Ireland at all. Uh, but when I was an undergraduate, there was a physics professor who would ask people to guess in class, and then if you were incorrect, he would make a buzzer sound. Are you at all surprised that nobody wanted to ask questions? No, not at all.
No.
Right? Of course they're not going to want to. But when you say, as you did, I don't know, but what a great question, and let's look into it, or how would we find out? Those are really great examples. You're modeling how to think critically.
Exactly. And I think part of what we've learned is that many students, and this is true, a lot of like even myself, like I will say this, and I've gotten in trouble for this. I'll say, I have a stupid question. That's ingrained in me. This is a stupid, I'm asking you this question. I know it's stupid, but that is ingrained. It's almost like a cultural thing for me.
Yeah.
And so I try to flip it, but it's there's just things I can't get out of my vernacular. But in a lot of cultures too, it's impolite in a way to question, right? So I think one of the things we've taken from recent years, and it's been around a long time, is just give your students opportunities to ask questions in other ways. So they don't want to put their hands up in class, fine. Have them ask questions of each other. So I use all the time, my students are driven mad by this, think, pair, share. I do it all the time. I just ask them, think about this, turn to the person beside you and discuss it. And if it's a larger question, I'll have them even break into groups of 4 and discuss it even more. And then I do other things like I use this all the time. 3-2-1 it's called. 3 things I learned, 2 things I found interesting, and 1 question I still have. And so I use that technique. It's very simple. It's a brilliant way to get your participation in your class, even attendance, because you know they did it. They participate in class. You don't have to take roll when you do this. It ticks a couple of boxes. But that 1 question I still have, I can flick through those, and then at the start of class the next day, I can ask that question, you see. So I think, like I said, it's the way that we put students on the spot. I mean, I know what you're talking about. I was put on the spot many of times when I was an undergrad, and it's not fun. You know, there's some students who like that, but others that really, really don't. So you have to find other ways. And again, that classroom agreement will tell you. Your students will say, there'll be 4 or 5 students that will say, I hate it when they put us on the spot. And so I say, well, I'm not going to do that, folks, unless it's something in the moment and I feel like I want to ask you something. But I'm not going to do it as a punitive thing. It's purely for us to learn. And so if you ever feel uncomfortable with the way I'm teaching you, come talk to me after class, put your hand up in the moment, address me right away. I will deal with that situation. But the whole point is to have a space where the students feel respected, valued, secure, brave, as you said. And like I said, and that's really, really important for me. So, and if a student ever came to me and said I wasn't doing that, I would be devastated because I'm failing as my.
I find it really interesting because though I didn't come up with this in class, I was really moved by a lot of reading that I had done. So I came up with my 3 agreements for the classroom. And the first is to always presume good intent until proved otherwise.
Amazing.
And the second is don't mind read. You don't really know what other people are thinking. Here's an example of that. Sometimes you'll get a question out of left field and you want to answer the question, but you want to bring it back.
Yes.
To where you're going. And I remember it happened one time and I did this. And what I was doing was thinking about a way to answer it, but the student thought I didn't like the question.
Yes.
And it's absolutely untrue. So I think putting that out there that you're not capable of mind reading, so that's why you ask. And the third is to be kind to others. And my students in my classes have been wonderful on that last. It really creates a sense of community in the classroom. And again, if you haven't done the reading, you haven't done the reading. I'm not mad at you about it. But often students come up with approaches, even when they haven't done the reading, that are really smart.
Oh, yes. Well, I'm still Irish, so I still have a touch of the Irish guilt. I'm very good at that. So if they haven't done the reading, they will
Do you,
feel it for me. So I'll be like, well, and one of my favorite, this is really mean. We were doing last semester, the student who did this will remember this, but we were in class, and I have a tendency to, what I try to do in my research labs is I try to ensure that there's enough repetition. Students don't like to do things more than once, they don't. But the goal of repetition is to give them an opportunity to practice and to iterate and to learn, right? So the students were compiling in, and I was talking about polymerase chain reaction, which is commonly used in molecular biology, right? And one of the students piped up and said, God, I could hear this. She's doing this PCR again. We've covered this a million times. I don't know why they always make us do PCR multiple times. And of course, I was listening to this, and I said, well, oh, you've stepped in it this morning now. I says, what's going to happen now? We're going to have a pop quiz on PCR. And I told them, we have a Chick-fil-A stand on campus. And I says, if every one of you can answer all of these questions, which we have covered in class, and I did them on the whiteboard, so you all took notes, and I know we covered this. If every one of you gets these questions right, I will buy each of you Chick-fil-A. I was having a particularly evil morning, but we did it. And so that same student, he didn't get everything right, and all of the students didn't get everything right. But the point of the pop quiz, not only to, everyone was laughing. This was a fun thing. But
Sure.
the point of it was to show them that even though you think you know, you don't really know until you're asked about it. And with something like polymerase chain reaction, I think there's a tendency among us as professors is we will cover a topic and we will examine the students, but we're examining them on exactly what we covered that day in that particular context, and we will assume they know the answer. With something like polymerase chain reaction, there's the textbook part, and then there's the application part and how you actually use it. And that's the most important part. So when you start digging into what they actually know, the students begin to realize, oh, I only know the theory. I don't really know how it works. And then they start to realize, now I need to understand what's happening, why it's happening, how it's happening. And that's when the learning in the laboratory becomes really important, because when they come into my lab as research students, having taken my research class, they know how to do PCR because they understand what's happening, not just this step is this, they understand what's happening at each step. And then when you have additional applications of PCR, like sequencing and all these advanced applications, then they can take what they've learned and apply it to a new context, and they're so much more confident. So honestly, the style of learning, it's not for everyone. But no. I have a very informal class, and my students are my colleagues in the class. They're leading the experiments. It's a lovely collaborative way of learning. And the students, honestly, I've had very few students say to me, I didn't enjoy this class over the years. But again, I'm privileged. I have the flexibility to do that. You know what I mean? Not everyone can. But if you can aspire to that type of learning environment where the students are peers, they're not your students, they're your peers, they're becoming scientists, they will be your peers, hopefully. You can have a much more engaging environment for the students to learn in. And it's much more fun for you. It's more fun for me. So,
and I would add, once again, that this applies to far more than science.
Absolutely.
This ability to question without blame.
Yes.
To actually analyze what you think and why, and to apply the lessons of collegiality and mutual respect that you have. And these are things that are without saying anything untoward, they're in short supply these days everywhere.
Yes.
And this is what I often tell students: the world is not fair, but this classroom and my laboratory will be as fair as I can possibly make it.
Well, I can give you another example. So we had some funding from the Teagle Foundation at Tamusa, and I had the opportunity I had developed a class at the New School called How Did Toilet Change the World? And I brought it to, I was asked, could you teach a first year seminar for us, Davida? And I was like, absolutely, I'd be delighted. And I said, could I do my toilet class? And they were like, absolutely, you work away. I had the pleasure of working with a student of mine, Aubrey, who was my fellow. And then we basically designed a first year experience class for the students. And it's I may be wrong, but it may be one of the first times a faculty member like myself, rather than first year seminar instructors, taught the class. So it was kind of like a pilot. And I said to him, I'm going to teach this class like I did at the New School. I'm going to throw everything at them, and I'm going to see, because I'm going to be frank here. I'm in Texas. I'm not in New York anymore. I don't know how that kind of class would work with a Texas student population rather than a New York population, which I was used to. So the toilet class is about social justice issues related to toilets, access to toilets, the design of toilets, the cost of toilets, public toilets, accessibility of toilets, everything. And it's such a random thing for the students. Like, why is she talking about? But if you study water, it's going to start at the toilet, right? And my father is a plumber, so I'm particularly attached to the toilets. But it was a fantastic experience for me because at the time we were going through the election, and so the vote was a part of what we were talking about with the students. And so obviously in a classroom like this, first years, they're coming from all over, and they will have different viewpoints. But because of the way I was teaching the class, when we came to the sections of the class that were related to talking about voting and, how you identify and all of this, that part of the class went extraordinarily smoothly. The students were so kind to each other, even when they had complete polar views on things. Because
that's the goal.
That's the goal. The way that we've been teaching the class is that every time we came up with a polar situation in the toilet world, when we started talking about this, it was actually very, very, I won't say it was easy, but you could see the students being kind to one another. And I said to the students, my most critical outcome for this class, the most important one, is I want you to develop your skills in empathy. I want you to be able to empathize with somebody else in your class. And I want you to take that with you from your first year class all through your degree. Because if you learn how to empathize with somebody else, not only will you be able to understand where they're coming from, but you might be able to engage with them in a way that you wouldn't have been able to otherwise. So, and that, like you said, is mission critical right now, because we do have folks on polar sides across the globe, not just in America, everywhere, where we cannot have civil conversations with one another and come up with ways to deal with issues that actually gets us to a place of solving those issues in a way that's equitable for everyone. And I think that's what we're seeing more and more today. So when I come up with issues of vaccines or climate change or anything like this, it's become so highly politicized that you're almost afraid to have an opinion. But at the end of the day, I'm a scientist. I follow my science. I eat, breathe. I always tell my students this, I eat, breathe, and sleep science. So for me, I'm always going to see things through a scientific lens. And if there is an alternate viewpoint for something, show me the evidence. Show me the evidence, and I will have that conversation. But until you have evidence for me that backs it up, it's not really an argument that I can relate to, right? So, and that's the conversation I have. So I've had students say to me, vaccines, I don't see why we should have to vaccinate, or my aunt is a nurse and I don't understand why she had to be vaccinated. And those are very difficult conversations to have in a microbiology classroom. So, but you have to have them, because you have to be able to have that conversation with anybody. Most importantly, with your microbiology students who are going to go off into the world and be advocates for microbiology.
Well, I say we need good microbial PR. I mean, I have right here.
Oh my gosh, yes.
Yeah, and I put so for listeners, the term germ carries a lot of freight today.
Yes.
And so what I did is I got myself a bottle of wheat germ, because Pasteur was the one who popularized the term germ, and he meant a piece of life, which is what wheat germ refers to. But if you ask any number of students, their knee-jerk reaction, the one-word response when they hear germ, it's uniformly negative. And this is because of the way that, and I'm not going to blame it on media, I think it's all of society, has collectively decided that that's a bad thing. Right?
I think that's changing. I genuinely think that's changing.
Good.
So I think that one of the things that we are doing, you see it even in the movies, and I always tell my students, one of my favorite things about, for example, not to plug a movie, but The Martian is one of my favorite movies. It has two of my favorite things in there: poop
and Matt Damon.
No, poop and potatoes. Poop and potatoes. The poop saved Matt Damon, and he grew potatoes. My two favorite things. Not to go stereotyping, but my whole mission my mission, aside from the empathy part, which is obviously a critical part of this, my mission is to reframe the narrative around microbes I do a lot of work on this. So for example, I have a project that's been going on for many years called Getting Friendly with Microbes, right? It started off as like the same thing, like almost like a dating profile back in the day, where we use e-portfolios. And the students basically have to design a website. It's a website. But I've given them prompts that aligned with the ASM curriculum guidelines with respect to things that they should know, right? So for example, structure, function, where they live, niches and all this. And I give them the prompts. But the goal is here that they have to do it in the first person. So they have to be the microbe. They have to become the microbe, because it serves two purposes. They can't copy that from the textbook or whatever, but also they have to kind of almost empathize with the microbe, right, in a way. So we're anthropomorphizing microbes, but I'm okay with that. But that's what they do. And I scaffold over the semester. And at the end, they present their e-portfolios. But there's a second part. The second part is that they have to make a creative work which goes with their microbe, right? And I give them free reign to do whatever they want. It could be a crocheted microbe. It could be a piece of pottery microbe. It could be a rap video. It could be a poem. It could be a comic book, whatever. And that in that process, they're connecting, because the portfolio is very clear. Am I good? Do I do good for the world? Am I only bad? Am I only ever able to do bad things? And so they see the multiple sides that microbes are alive and they're essential and they're, contributing to the world. They're really important. But this creative thing, they start to kind of go, oh, micro is fun and all of this. And we put the two things together. It's a marvelous way to get them engaged. And so basically, to quote to talk about an Irish word, I try and bring as much crack into the class as I can. Crack, CRAIC, fun, joy. Because my rubric for this assignment, the actual rubric I use for the creative work, is the Marie Kondo rubric. Did it spark joy or not? And I says, if it makes me giggle, you get credit for your creative work, and that's all I'm looking for. But I genuinely believe that the ASM curriculum guidelines that just came out, if you haven't read them yet, folks, make sure you go on there, because we are trying to actively in those guidelines reframe how we see microbes from pathogens. It's a pathogen heavy, blah blah blah. They're bad for the world. Into they're essential for everything, and they're mostly good. The vast majority of them are mostly good. So.
Well, I mean, it's there's so many similarities to the way that you think and the way that I think, and that's because we're both so brilliant, right? That's what it comes down to.
We're clonal.
So I don't know who's being complimented there. I'm me.
We're Irish, remember? We're probably
that's correct. It could be that way. So anyway, one thing I've done similar things to this, and you really, I like your idea of first person, because when I have my students do a term paper, which I call, because I'm goofy, I call a microbiography.
That's brilliant.
And then I have them do a 1-page version of that for an English major.
Yes.
And I call that a nanobiography, and they just hate doing that.
Oh.
But what they don't understand is that if they were able to explain their topic, their organism of choice, to an English major, and I'm not putting down English majors at all, okay? Try having an English major tell a microbiology student to write something in iambic pentameter, right?
Oh boy.
It's the different kind of thing.
Yep.
But what I'm trying to get at is they're really resistant because they have in their minds what the right thing to do is. And I really like your first person idea. I really do. And I've been known, I years ago I had the artwork, and I'll have to send it to you. Most people think of devil microbes, which is the way that, or now, and this is just as bad, the angel microbes, right?
Yeah. I mean, again, it is the PR question. But
it is.
So one of my most prolific collaborations is with I'm just going to say this, with an English literature professor. Her name is Teresa Conifrey. I know her from Censor. I've worked with her forever. And what she does is, her job is to teach the engineers in her school technical writing and stuff like this. And what she's been doing, and this is why we get along so well, because she's Censor, her technical writing focuses on things that are topical. For example, electric cars, right? These self-driving cars that they're not driven by people. And at the time, the word on the street was they're inherently dangerous and they cause all these accidents and everything else. So she would have her students take an issue like that, the engineers now, and they have to write a manual, effectively, a piece of technical writing goes along with that. But going to the source, evaluating the source, looking at the source. Is it true? Is it not true? What is the evidence for this? And so she's effectively teaching them how to be scientists. And I know they're engineers, but teaching them how to be scientists. But she's doing it in the context of an English class. And I says, that's where we really see the way that we can work together, because one of the worst things we do is the fact that we've created these silos, right? So, and in the sciences, we're even worse at it. Chemistry is its own thing. Biology is that's insane. We can't teach microbiology without chemistry. You just can't do it. So one of the things I've been doing here is I've been trying, and I've been doing other places too, and I do it through Sensor, but I have colleagues here, and I've been trying to get us to just work together on how we teach the same thing. So how the chem teacher teaches pH versus how we teach pH, right? And if we were to talk with each other on how we could develop a lesson plan around pH, the students would see the connections between those two courses and take some of what they know from chemistry into their biology class, which would be amazing. We don't do that enough. We just don't do it enough. So I think that if we can kind of start breaking down the silos amongst our disciplines, our students would learn better in a more integrative way. And therefore, they would be able to take what they're learning in one class into another. We wouldn't be on our own trying to teach them everything. Do you know what I mean? And that's a big issue. So, yeah.
Well, I think that there's a saying in physics that physics advances by gravestone by gravestone.
Oh boy.
And I thought you'd like that style of humor. But the reason that I bring this up is that some people are very resistant to change. I'm guilty of it too. And so you have to, when you say, for example, well, I'm going to combine chemistry and biology, and we've tried to do that here.
Yeah.
And there's all these turf battles that occur. And then some people don't want to try it because they have to leave things out.
Oh, yes. That's the age-old argument, right?
Right.
Even among the biologists.
Right. And so what's really important is for me to put aside, when I was teaching introductory biology, my love of X, Y, and Z, and think to myself, what do I want the students to know when they finish my class, that like a lunchbox that they pack? I actually had a student create a diagram of a lunchbox with various things from class on it, which was really lovely. But because I too think that creative stuff really helps. It's looking at things differently. But we all have to be open to change is the point.
100%.
Because I really, really think that we need a lot more critical thinking, and we're not getting it. So we have to do it. And it doesn't mean question everything. When I drop this pen, it's going to fall. If it flew upwards, that'd be kind of awesome, but it won't, right?
Yeah, but again, it's like, why does it fall, right? Why does it always fall? So I think another thing is like, what we're doing now, it's not like it hasn't happened before. We've had these conversations, right? So what's important, what's not important? Vision and Change, the Vision and Change report, which maybe not all of your listeners aren't familiar with, but the Vision and Change report was a national effort of educators and scientists and everything else to come up with a framework through which we can teach. Vision and Change has been around more than 10 years now, and it hasn't penetrated all of the biologists, let alone the microbiologists, but the framework allows us to identify what are the most important things we want our students to get, not the nitty-gritty stuff, because they have a limited amount of RAM up here, of memory that they can put things into. And if you, just because you teach it, remember I brought it back to repetition, just because you teach them something once and they ace it on an exam does not mean they're going to retain it. So I think what I'm trying to get at here is that the more exposures they can have to something in different contexts, the more likely it is that they're going to learn. So I'm not necessarily saying we have to merge the classes. What I'm saying is we have to be synergistic in how we teach the classes. So think of it this way. In stats or in mathematics, right? And this is why I never did well in math, right? You're learning about this equation, right? Or you're learning about logs or whatever it is, and you're learning about it in an abstract way. Why not take a water quality problem? E. coli was detected in this water sample. It's going to grow every 20 minutes because the person left it on the bench. They didn't refrigerate it according to the protocol. And it's going to double every whatever. Plot this curve and figure out the rate. That would have been a way easier way for me to remember how to calculate rates, because there's context there. So if the context was brought in a way that, connected our disciplines, that's a simple step that we could all be doing, right? So it doesn't mean we have to drop the boundaries altogether, but I think we can be synergistic in how we teach things, and that would help students retain things because they don't.
I agree. I agree. And a good example of that. That's not what I meant. It's like, oh yes, I agree. No, that's not what I meant at all.
No, I got you.
What I mean to say is that there's a way that we teach things in my department, which has actually surprised me at how well it works. Routinely, I would get advisees who tell me they're very allergic to mathematics.
No, yes.
And they'll always say that because someone, again, in their past told them bad things. We're all gonna give wedgies to who did that, because
Yes.
it's probably just one person in their history.
Yes.
In any event, what folks do in ecology here is they actually use a lot of statistics in our ecology classes.
Yes.
And those same students don't have any trouble with RStudio. They don't have any trouble with evaluating statistics, just as you said in your example with wastewater, because they have something tangible to connect it to. I'm not taking anything away from mathematicians. I'm married to one. But I will say that for many people, they need to see that kind of application.
Yes.
And then maybe afterwards, they would see the beauty inherent to mathematics. You're welcome, Jenny. So I put it in there carefully, didn't I?
You did. You laid it out for her. Listen, I have some of my best friends are mathematicians. And again, it comes back to sensor. We had this whole project called Engaging Math, right? And it was doing exactly that. So all of us in sensor teach through issues, teach through context,
Mm-hmm.
make everything relevant. It's all about the relevance, right? And when if I was to bring you back to content overload, we have another project, and it's NSF funded, called the Improving General Education. It's not improving now, but it's iGELS it's called, right? It's to effectively improve the general ed life sciences classes. And the reason being is that what we've been seeing is that we want everyone, as many people as we can, to at least look at the world through a scientific lens, to a critical thinking lens, to understand how this can be used to enrich your life, okay? General ed classes in a lot of schools, I won't say everywhere, but in a lot of schools are kind of like afterthought, right? These are the filler classes that anyone should have to take. And in other cases, it might be your intro bio class that is a class that everyone has to take, even if they're math majors, right? Now, the thing is, the way that we teach intro bio or life science classes, we just throw everything in there. Everything. You have to know everything. It's not about how to use science. It's about all of these factoids like photosynthesis and the Krebs. No one needs to know all those steps. I don't even remember all those steps. I have to check because I forget things. I'm like a goldfish. I'll check the book. But here's the thing. If we pared it down as to what's important, it's like you said, you want people to be able to, for example, explain a scientific concept to anyone in a way that they will understand it. That is a critical skill to have. Be able to, evaluate sources, right? Evaluate sources to see if they're credible. That is a critical skill that anyone would have, because that boils down to things like this. A student bringing me in a shampoo from a company that will remain nameless that said it was microbiome friendly, right? And the same shampoo was $34. It was $34. So same thing. I challenged the student. I said, well, what do you think they're doing here? And she says, well, it's a marketing thing, obviously. And I said, yes, it is. And I says, what I want you to do for me now is I want you to go through that list of ingredients and compare it to any other standard shampoo that's out there and tell me what of those ingredients makes it microbiome friendly. And so she did the activity. She did the homework. She came back to me. She said, nothing. And I said, that's what I'm saying. A lot of these things are marketed in a way that's not regulated. There's no control over what words you use for these things. So you can say whatever you want and people will believe you. So I always say that the one example I always use is Purell. I hate Purell. And I say Purell is genocide for your friendly microbes. I says Purell was designed for clinical folks who haven't got time to wash their hands, right? It was designed as an emergency thing in clinical settings, right? Not to replace hand washing. And I says, what's happening now is y'all are out there using this in lieu of hand washing. You're not washing your hands. And I said, hand washing is the most important thing. So I'll watch students go to the vending machine and take out whatever, put in their money, take out whatever, and then they'll go back to their desk and then they'll break out the Purell or whatever, if at all, and start eating their things. My favorite activity was to contact plates. Press them on those vending machine buttons and show them all the E. coli that's on there. I says, what you're not realizing is all of these things, you're being effectively, you're almost being misled because of the fear we have of microbes or the little knowledge that we have of microbes. And so you have to be able to look beyond what you're being told and evaluate it and say, that doesn't sound right. That can't be true, right? So be cynical about things. And I think you won't fall for the $34 shampoo problem at that stage. So that's the goal.
It's important to also say, because I've had this come up, this transmission of cynicism about things.
Yes.
And that's a stage of this process of critical thinking.
Yes.
But you need to get past that, or get the students past that, our colleagues. Students sounds diminutive. We have to come up with a new term, right?
Exactly.
Our clients,
yes.
right?
Yes.
Our educational clients, our ECs.
Yes.
We have to be able to get them to a place where even if they disagree, this comes back to your empathy thing.
Yes.
Right?
Yes.
I mean, most of us have a relative that believes in things that are kind of nonsensical for one reason or another, and we still love them and think well of them.
We try.
And we need to grant that grace to other people, because if I will promise you, calling people names does not change their mind.
No, and I think it basically, like, you just have to watch, even with what's happening right now, even with the highly political world that we live in right now, you're still going to have situations where our senators, our congresspeople, whoever they are going to have to make decisions together, right? They're going to have to. And they're going to have to balance their wants, needs, the party, whatever, with their constituents and everything else, and try and come up with decisions that make sense, right? If that behavior can't be, exhibited for people to see, we're doomed. We're doomed. So if we can't have conversations with one another and try and empathize with one another and make each other understand where we're coming from, you're not always going to make everyone agree with you, but at least they'll begin to understand where you're coming from. And that's really important. So for me, having someone say, I have very simple ways of looking at the world. I'm Irish, right? So I come from free healthcare, free education, free things that just make so much sense to me. But that is not something that everybody necessarily agrees with here. So being able to talk to people as to why it's important. Why is free education important to me? I'm what we call a first gen student, right? My parents didn't go to university and didn't finish high school. My father became a plumber, became an apprentice, right? But my parents instilled a value for education in me from the get-go. My father got me my first position. He was working in a doctor's house and he was going on about his daughter, how she was into science. I was like 14 or so. And the doctor was very well-to-do, and she was the pathologist at a hospital in Dunleary. And she basically said, well, would she like to come into the lab and check out the lab? And my father was like, sure she would. So I got to go into a clinical microbiology lab as a 14-year-old. And I was in love because I got to see pee and poo and sputum and fungal nails and all these disgusting things. And the micro lab, unlike the other labs, was very hands-on. A lot of the other labs, histology, biochemistry, robots. Even then it was robots, right? But microbiology was pure and simple problem solving. Patient is sick. Here's the sample. Why is the patient sick and how can we treat them? It was the most amazing thing ever. And you've no idea. You have you can whittle it down, but you really don't have an idea what it might be. It could be all these things. It's the perfect. If you're Sherlock Holmesy, if you are Dana Scully from the X-Files, whatever it is, you're going to want to solve this case, right? And so that's what microbiology is for me. And it's also an understanding that microbes are in communities. They're not alone. They're always with their friends, right? And so that was kind of the first thing, is that microbes don't live alone. They don't. They live in communities. No. So that was the other thing. And they get along, they work together most of the time. And so I think, like I said, it's a case of getting folks into it in a way that, makes them see the world through a microbial lens is really important. And having them to be able to think that way in every aspect of our life is the goal. And being able to do it in a way that doesn't enforce your views on somebody else. You have to listen, really listen, understand where they're coming from, try and relate to them in whatever way you can, and then try and inform them as best you can without being patronizing. And that is not a skill that most scientists have, to be frank.
No.
We don't, because we think we know everything. But remember, Sensor tells you don't know everything. Science is limited. So.
You have to invite me out to give a talk, because
I'd love to.
I have this talk that I give teaching students to see with microbial eyes. And there are so many parallels in what we're saying. To wrap all of this up, Dvita, do you have any advice for listeners and viewers who aren't microbiologists, who maybe aren't scientists, maybe are outside the standard scientific silos that we've discussed today, on how best to sensitize themselves to critical thinking as they encounter so much of our media, since so much of our media seems to be directed toward kind of sound bites and factoids?
Yeah, I think a couple of things you can do. I mean, the first one is the most simple. It's just to read as much as you can. There are some lovely scientific books out there. And I love people like Carl Zimmer. I'm a huge fan of Carl Zimmer. But reading is a great way to do it. And you can get some books on your phone and be listening to your books on your phone. Another thing to do is subscribe to podcasts, right? So Vincent Racaniello, as you all know, This Week in Virology, and Mark's podcast. There are many, many, many scientific podcasts out there. There are also a lot of YouTube channels that are run by people who are necessarily non-scientists, but they do scientific work. So there's some wonderful engineering things on YouTube that you can follow. And then the last thing I'd suggest you do is that you can, well, there's two ways you can do it. You can get involved in some community science organizations that are in your neighborhood. These are everywhere, right? And so it could be something like River Keepers or Texas Stream Teams that we have down here. Get involved in your community science stuff. It could be something as simple as a river cleanup, or collecting samples, or going looking at pollinators. Get yourself iNaturalist, stick it on your phone and start taking photos of things. But community science is a great way to get involved. And that by doing so, you'll be working with other people who also think scientifically or are interested in science. And oftentimes the community scientists will have connections to the universities and the other scientific organizations that can get you further in. But that's the first thing. Start reading, get your books, even go down to the library and get some books from the library. Get onto the podcasts, right? Subscribe to some YouTube channels, and then get involved in some community science and give back to your community in a scientific way. That's what I would advise.
That's great advice. Thanks. And I cannot express to you what a wonderful time I've had chatting with you this morning. It has been just wonderful to hear your passion for the educational side. We haven't even talked about your science.
Oh,
but
yes.
that's okay.
Yes.
And the reason that's okay is I'm going to put links to a lot of stuff, including your fabulous website, by the way.
Oh, thank you.
in the show notes. And I owe you several emails about questions that I have about science as well. And you've really sparked a lot of enthusiasm in me, and I hope in every listener and viewer.
I hope so too. And remember, if any of you are going to be around for ABRCAMS or ASMQ, it's going to be in San Antonio this fall in November.
There it is.
I hope you're all registered. So, and Mark, I'm going to be hoping you come because we can hang out then.
That'd be fun. I always have a fun time around you. So my very best wishes to you in your cave.
Thank you.
And we'll have to share Colin Farrell stories another time.
Anytime. And up the
Thank
go.
you so much.
Bye.
This has been Matters Microbial, a weekly podcast about the wonders of our microbial world and the people who study it. You can send questions, suggestions, or comments to me at mattersmicrobial@gmail.com. Show notes from today's episode with epic links, as always, can be found at microbe.tv/mm. If you like our work, please consider supporting us at microbe.tv/contribute. I'm Doc Martin, and you can find me in the biology department of the University of Puget Sound in Tacoma, Washington. Dr. Dvita Smith is Professor of Biology and Deputy Director of the National Center for Science and Civic Engagement at Texas A&M University-San Antonio in San Antonio, Texas. Many thanks, as always, to David Renata for superb editing and Reber Clark for the wonderfully quirky music that makes me smile each time. I hope that you've all enjoyed being part of our Quality Quorum for today. See you next time on Matters Microbial.